Hello friends, so welcome to a lecture series on multivariable calculus. So we have already discussed so many properties of several variable functions. In this lecture we will deal with tangent planes and normal lines. How can you find out tangent plane to a surface and a normal line at a point, okay. So first let us discuss this proof. Let R be given by gt I cap plus ht j cap plus kt k cap is a smooth curve on a level surface f x y z equal to c on a differentiable function f. Okay. So suppose you have some surface f x y z equal to c. Suppose R t, which is given by gt I cap plus ht j cap plus kt k cap. Okay. Say this smooth curve passes through this surface. So what will be the value of function on this surface? So where f on this surface will be given by f, you simply replace x by gt, y by ht and z by kt. So what you will obtain? It is gt, ht and kt, okay, kt is equals to c. Now you differentiate both sides with respect to t. When you differentiate both sides with respect to t, what we will obtain? Now we will apply chain rule on this side. This is del f upon del x, because f is a function of x, y, z and x, y, z are in turn are the function of t, variable t. So what you will obtain? Del f by del x into dx by dt plus del f by del y into dy by dt plus del f by del z into dz by dt, which is equals to 0. So I differentiate both sides with respect to t. Okay. Now this can be written as del f by del x I cap plus del f by del y j cap plus del f by del z k cap, and dot with dx by dt I cap plus dy by dt j cap plus dz by dt k cap is equal to 0. So basically what is dr by dt? Dr by dt is same as dx by dt is same as dgt by dt, because x is simply gt and y is simply ht, z is kt. So dx by dt is simply dg by dt. Okay. Now what this is? This we call this as gradient of f. We call this as gradient of f. What is del operator? Del is I cap del by del x plus j cap del by del y plus k cap del by del z. This operator is called as del operator. Okay. And del of f will be I cap del f by del x plus j cap del f by del y plus k cap del f by del z. Okay. So this is simply this thing and we call it gradient of f. Okay. So this we call as gradient of f. Dot with, now what this is? Now when you find dr by dt of this equation of this vector, so dr by dt will be dg by dt I cap plus dh by dt j cap plus dk by dt k cap. Okay. Now so this is same as this vector, because dx by dt is nothing but dg by dt, because x is nothing but g. So we can say that this vector is nothing but dr by dt and this is equal to 0. Okay. Now this dot product is 0, this means the angle between them is dot product a dot b is simply mod of a mod of b cos of angle between them. And if cos of angle between them, that is cos theta is 0, this means theta is pi by 2. that means this vector is perpendicular to this vector. So, this implies gradient of f is perpendicular to dr upon dt. Now, what dr upon dt represent? Dr upon dt represent velocity vector of this smooth curve, okay, or we can say tangent at a point t, dr upon dt, I mean slope, sorry, which we can say a slope. Okay. Now, this is perpendicular to del f, that means del f is normal to a surface, because this is basically perpendicular to a tangent, and if this is perpendicular tangent, this means del of f give normal to a surface. If you have this type of surface, this is f basically of 3 variable x y z, then gradient of f at a point x y z simply give normal to the surface. Okay. So, we can say that at every point along the curve, gradient of f is orthogonal to the curve's velocity vector. If we consider all the curves that passes through a fixed point p naught, hence all the velocity vector at p naught are orthogonal to gradient of f at p naught. So, the curve's tangent lines all line the plane through p naught is normal to gradient of f. Okay. So, what gradient of f gives at a point on the surface? Gradient of f simply gives a vector normal to a surface. Okay. Now, suppose you want to find out a tangent plane at a point x naught, y naught, z naught. So, how will you find? Now, you have a surface, okay. You have some surface f x y z equal to c, and at some point x naught, y naught, z naught, you want to find out a tangent plane. Okay. Now, the tangent plane, we know that gradient of f at a point x naught, y naught, z naught is normal to a surface. So, it will be a normal to a tangent plane also. So, direction ratios of the normal to a direction ratios of the normal to a tangent plane are del f by del x at p naught, del f by del y at p naught, and del f by del z at p naught. Okay. Now, suppose you want to find out a normal line at a point x naught, y naught, z naught. Now, this is a surface and you want to find out a normal line. Now, gradient of f is normal to a surface at p naught. So, gradient of f is also normal, and normal line is also perpendicular to the surface at that point. So, gradient of f will be parallel to, normal line will be parallel to gradient of f at p naught. Okay. Now, so this is a geometrical representation. If you have a surface this, okay, this is a tangent plane. So, gradient of f will be a vector normal to a surface. Now, how can you find the equation of tangent plane and normal line? Now, suppose this is a surface, okay. At some point p, which is x naught, y naught, z naught, you are interested to find out the equation of tangent plane. The equation of tangent plane at this point p, okay. Now, gradient of f will be normal to this point, gradient of f at p naught, at p, gradient of f at so we are calling this point as p naught, so it is p naught. Okay. So, gradient of f at p naught will be a vector normal to a surface at p naught. Okay. Now, let us take an arbitrary point on this plane, say this point is x, y, z, p point. Let us take an arbitrary point x, y, z on the plane p, on the plane on the tangent plane. So, what will be the direction? What will be the direction ratios of this vector? What will be the direction ratios of this vector? So, direction ratios of p naught will be x minus x naught, y minus y naught, and z minus z naught. Okay. This will be direction ratios of this vector. This is x minus x naught, y minus y naught, z minus z naught. What is gradient of f at p naught? This will be fx at p naught I cap plus fy at p naught j cap plus fz at p naught k cap. Okay. Now, what this p naught will be? X minus x naught I cap plus y minus y naught j cap plus z minus z naught k cap. Now, since gradient of f at p naught is perpendicular to this line, you see you have a tangent plane, like this, okay. On this surface you have a tangent plane, and you have taken an arbitrary point on a tangent plane, and this x naught, y naught, z naught is a fixed point on the plane. So, this vector, this p naught will lie on the tangent plane, and gradient of f is normal to the plane. So, gradient of f will also be normal to to the vector p naught. So, we can easily say that p naught vector will be perpendicular to gradient of f at p naught. So, this implies fx at p naught into x minus x naught plus fy at p naught into y minus y naught plus fz at p naught into z minus z naught will be 0, and this will be the equation of tangent plane at p naught. Okay. So, if you are interested to find out the equation of tangent plane at a point p naught of the surface fx y z equal to c, so we can simply apply this equation to find out the equation of the tangent plane. Okay. Now, let us think about normal line. Now, if we want to find out the equation of normal line on the surface fx y z equal to c at a point p naught, which is x naught, y naught, z naught, we want to find out the equation of normal line. So, you have this surface. Okay. Now, this is p naught, which is a fixed point on the surface, and you want to find out the equation of normal line. So, take a arbitrary point on the normal line. Okay. Take arbitrary point on the normal line x, y, z, say p. P may be any point on the normal line. So, again what will be the vector p naught? The vector p naught will be x minus x naught I cap plus y minus y naught j cap plus z minus z naught k cap. Now, this vector is where? This vector is on the normal line, normal to a surface, and gradient of f is also normal to a surface at p naught. So, both vector are normal to a surface, that means both are parallel. Okay. So, we can simply say that p naught vector will be parallel to gradient of f at p naught. Now, since they are parallel, this means they have a same ratios. The ratios will be same. That means x minus x naught upon fx at p naught will be same as y minus y naught upon fy at p naught and z minus z naught upon fz at p naught, because this vector is parallel to this vector. Now, if two vectors are parallel, this means one will be lambda times other vector. Okay. If this vector is parallel to this vector, this means this vector, any one of the vector will be some lambda times other vector. Now, this vector is x minus x naught I cap plus y minus y naught j cap plus z minus z naught k cap will be equals to lambda times gradient of f will be fx at p naught I cap plus fy at p naught j cap plus fz at p naught k cap. So, from here if we equate the coefficients, so x minus x naught upon fx at p naught will be equals to y minus y naught upon fy at p naught will be equals to z minus z naught upon fz at p naught, and that will be equals to lambda. So, the same equation is here. Okay. So, in this way we can easily find out equation of normal line. So, that will be normal line. You can take t or lambda, it hardly matters because the parameter. So, these are some problems. Let us try to solve these problems. The first problem is x square minus 4y square plus 3z square is equal to plus 4 is equal to 0, and the point P naught is 3 to 1. Okay. So, this is basically f. Now, you have to find out the equation of tangent plane and normal line at a point P naught. Okay. So, first we will find del f by del x, it is 2x, and del f by del x at P naught will be 6, fy which is minus 8y. So, fy at P naught will be simply minus 16, fz is 6z, and fz at P naught will be 6. So, what will be the equation of tangent line at P naught? It will be equation of tangent line at P naught will be, it is fx at P naught x minus x naught plus fy at P naught y minus y naught plus fz at P naught z minus z naught will be equal to 0. To remember this equation, you have to simply remember that the gradient of f is always normal to the plane, I mean normal to a surface at a point P naught. So, if it is normal to a surface at a P naught, so if you take a vector x minus x naught, y minus y naught, z minus z naught on the tangent plane, so both are perpendicular, that means dot product will be 0. So, if you take the dot product, you will simply get back to this equation. What is fx? Fx is 2x which is 6 minus 8y which is 16 and 6z which is 6, yeah, tangent plane. So, equation of tangent plane. Okay. Now, what is fx at P naught is 6, x minus x naught is 3, it is x naught, y naught, z naught, fy is minus 16, y minus y naught plus fz is 6 and z minus 1 equal to 0. You divide the entire equation by 2 which is 3 x minus 3 minus 8 y minus 2 plus 3 z minus 1 equal to 0. It is 3x minus 8y plus 3z, it is minus 9 minus 16 and minus 3. Yeah, it is plus 16. Okay. So, it is plus 16. So, it is minus 12 plus 16 is plus 4 equal to 0. So, this is the equation of the tangent plane. Now, how can you find the normal line? So, normal line will be x minus x naught upon fx, y minus y naught upon fy at P naught, and z minus z naught upon fz will be equals to t. So, x will be given as 3 plus 60, y is equals to 2 minus 16t, and z equal to 1 plus 6t, where t is any real value. Okay. So, this is normal line. Now, for the second problem, so what is f here for the second problem? It is cos pi x minus, it is x square y plus e raised to power x z plus y z is equal to 4, and the point is 0, 1, 2. So, first we will find fx. What will be fx? Fx is minus pi sin pi x minus 2xy plus z times e raised to power xz, and fx at point P naught will be, when you substitute x as 0, y as 1 and z as 2. So, this is 0, this is 0 and this will be 1 and z is 2. So, it is 2. Now, what is Fy? Fy will be minus x square plus z, and Fy at P naught will be x is 0 and z is 2. So, it is again 2. Now, Fz is x e raised to power xz plus y, and x is 0 and y is 1. So, Fz at P naught is 1. So, equation of tangent plane will be at P naught will be, it will be 0 into x minus x1, okay. It will be fx at P naught, that is 2 x minus 0 plus 2 y minus 1 plus 1 z minus 2 equal to 0. So, this equation will be simply 2x plus 2y plus z, and it is minus 2 minus 2, that is equal to 4. And equation of normal line at P naught, normal line at P naught will be, it will be x minus 0 upon 2, y minus 1 upon 2 and z minus 2 upon 1. Let us suppose equal to t. So, x will be 2t, y equals to 1 plus 2t and z equals to 1 plus 2t, where t is any real number. So, this will be equation of tangent plane and normal line. Now, if we have a equation of surface like z equals to fxy, okay, if we have the equation of surface like z equals to fxy, so take all the things on the one side. So, what will be capital Fxyz? It will be Fxy minus z equal to 0. And suppose at a point P naught, which is x naught, y naught and z naught, you want to find out equation of tangent plane and normal line. So, what will be the equation of tangent plane and normal line for this curve? So, basically this is a special case of the first part. So, this will be fx at P naught, x minus x naught, this will be fy at P naught, y minus y naught plus fz at P naught into z minus z naught equal to 0. So, what is fx at P naught from this equation? It will be fx small f at small fx at P naught, x minus x naught, okay, plus small y fy at P naught into y minus y naught, and what will be fz at P naught? It is minus 1 always. So, it is minus z naught equal to 0. And similarly, the equation of normal line at P naught, which is x naught, y naught, z naught, will be x minus x naught upon fx at P naught, y minus y naught upon fy at P naught and z minus z naught upon fz at P naught. So, this implies this is x minus x naught and fx at P naught is a small fx at P naught. This is y minus y naught, and similarly it is fy at P naught, and it is z minus z naught upon minus 1, and say it is t, fz is minus 1. So, x will be x naught plus t times fx at P naught, y will be y naught plus t times fy at P naught, and what will be z? Z will be z naught minus t, where t is any real number. So, this will be equation of tangent plane and normal line at a point P naught for this surface. Suppose you want to solve this problem, find the equations of tangent plane in normal line to the given surface. Say we take the first problem, similarly we can solve the second problem also. So, it is z is equals to e raised to power minus x square plus y square, and the point is 0 0 0 0 0 1. So, how can we solve this? So, tangent plane will be, so tangent plane at P naught will be, so you first find fx. So fx simply is this function, okay. So that will be minus 2x e raised to power minus x square minus y square, and at 0 0 1 it is 0, and fy will be again minus 2y e raised to power minus x square minus y square, and fy at P naught will again be 0. So the equation of tangent plane will be 0 into x minus x naught plus 0 into y minus y naught minus 1 into z minus z naught. So this implies z equals to 1. So this is the equation of tangent plane at this point for this curve, and normal line at P naught will be x minus 0 upon 0, y minus 0 upon 0, and z minus 1 upon minus 1 equal to t. So you can take this will be z is equals to minus t plus 1 for any t. Similarly, we can solve the next problem. Now, how to find tangent line to the curve of intersection of surfaces? Okay. Now, let us discuss this thing. Now, suppose you have two surfaces. Okay. Suppose you have two surfaces. This is one surface and this is second surface. This is f equal to c and this is g equal to some k. Okay. And this is the point of intersection. At this point of intersection, you are interested to find out the equation of tangent line. It will be some tangent line, because two surfaces are intersecting each other. So it will give a tangent line. Okay. Now, how to find the equation of tangent line at this point? Now, gradient of f, suppose this point is P naught, at P naught will give a vector normal to the surface at P naught. Okay. So it will be definitely normal to a tangent line also. Similarly, gradient of g at P naught will give a vector normal to the surface g equal to k at P naught. So it will be perpendicular to, or it will be normal to tangent line also. So this is also normal to tangent line at P naught, and this is also normal to tangent line at P naught. Now the cross product of these two vector will give a vector normal to, I mean when you are having two vector a and b, cross product of this give a vector normal to both a and b. Okay. So cross product of these two will give a vector normal to both the vectors, normal to this vector and this vector, and hence when it is normal to this and normal to this, so parallel to this, because these two are normal to this tangent line. Is it clear? Because this is normal vector, normal to f at P naught, so normal to tangent plane also. Similarly, this is also normal to a tangent plane at P naught, and the cross product gave a vector normal to both the vector this and this. So the vector which is obtained by the cross product of these two vector will be parallel to a tangent line. Okay. So in this way we can get the equation of tangent line. Say V is the vector which is cross product of these two vector. Okay. And say this vector is V1 I cap plus V2 j cap plus V3 k cap. So, what will be the equation of tangent line at P naught? Will be x minus x naught upon V1, y minus y naught upon V2 and z minus z naught upon V3, because both are parallel. You see, x minus x naught, y minus y naught, z minus z naught is a vector lie on the tangent line, and vector v is also parallel to tangent line. So, both will be parallel, this means ratios will be same. So, in this way we can find out the equation of tangent line when two curves are intersecting. Say we have first problem, okay. So, f here is x y z equal to 1 and g here is x square plus 3y square plus 6z square equals to 6, and the point is 1 1 1. So, what will be fx? It is yz. Fx at P naught is 1, similarly Fy at P naught is 1 and similarly Fz at P naught is 1. Okay. What is Gx? Gx will be 2x, Gy will be 6y and Gz will be 12z. So, Gx at P naught will be 2, Gy at P naught will be 6 and Gz at P naught will be 12. Okay. So, how to find V now? V will be equals to cross product of these two vectors, that is I cap, j cap, k cap. This is 1 1 1, this is 2 6 12. The cross product of gradient of f at P naught and gradient of g at P naught, this will be V. So, this vector will be the, suppose this vector is V1 I cap plus V2 j cap plus V3 k cap, that we can easily find. Okay. Then the equation of tangent line will be x minus 1 upon V1, y minus 1 upon V2 and z minus 1 upon V3, which is t, say. So, this will be equation of tangent line at P naught. So, similarly we can solve the second part also. So, these can also be solved using the properties of tangent plane and normal line, these problems. So, thank you very much.